right, kissers, now that we know a little bit more about transformations, let's take a look at this think aloud. It says these two functions below are given. So I have h of x and I have q of x. And my question is, what does the graph h compare to the graph of q? So in this case, I do not have a graph in front of me to let me know what is going on between these two equations. However, my first task is to note what is different between h of x and q of x. I notice between these two functions that my slopes are different. H of x has a slope of 2, and then q of x has a slope of 1/2. Here's a little note. I know if the number that is my slope is bigger than the other one, it's going to be steeper. So I see 2x, I know that is going to have a steeper slope compared to 1/2. So I want to put that as a note. Have a steeper slope, that means q of x that has the slope of 1/2 will be less steep. So now I'm going to answer my question. It's saying, how does the graph of h compare to the graph of g? So I'm going to be looking at the equation h of x, and I'm going to circle our notes right here. I want to write a sentence that will state that this slope is going to be steeper. So my sentence is, the graph h of x is steeper than the graph of q of x. So just to recap what I did is I first circled what was different from each equation. I noticed that the slopes were different, and I know slope value that is bigger is going to be steeper compared to the other one. So I just compared and looked, 2 is bigger than 1/2, so I know that equation is going to have a steeper slope. All right, let's take a look at this one. This one's a little bit different. However, it still wanted me to compare the graph of h compared to the graph of q. So the very first thing I want to note what is different. I automatically see that my constants are different, but my slopes are the same. So I can say that h has the same slope as q, but different y-intercepts. I noted what was different, and I created a sentence. So in this case, the slopes were the same, but the y-intercepts were different. Remember, the constants are the same as your y-intercept. We're going to look at one more. Let's take a look at this one. I first want to note what is different. I automatically see that my slopes are different. On h of x, I have 5/8, and then q of x, I have 8/5. I want you to be very careful because I know fractions kind of scare some of us. If that is the case, you can convert these into decimals if you wish. So you could compare which one has a greater value. Because remember, if it has a greater value, we know it's going to be steeper. So let me plug that into my calculator so you can see. So I noticed 5/8 does give me the decimal of 0.625. And then Q, 8 divided by 5 gave me the 1.6. So I know the greater value will give me a steeper slope. So that means Q of x is going to be steeper. If I know it's going to be steeper, Q of x, that means h of x is going to be less steep. So I'm going to be writing that because it still wants me to compare graph of h compared to the graph of q. So I know I'm going to be writing something about the slope being less steep. The sentence that says the graph h of x is less steep than the graph of q.